Welcome to this video on Spec-Driven AI DevOps. We'll explore how to move beyond vibe coding to govern the new era of agentic software delivery. Autonomous agents have accelerated code production, but they also risk creating architectural drift. Spec-Driven development serves as a mandatory governance layer to bind AI execution to enterprise intent. Vibe coding often relies on an ephemeral exchange of intent. Without proper documentation or peer review, agents can make hallucinated decisions, leading to invisible tech debt and fragile code bases. In the traditional approach, code and requirements often age poorly. With spec-driven development, we focus on structured specifications to reduce uncertainty, enabling continuous refinement through a bidirectional feedback loop. Conversational prompt engineering can result in untraceable architectural drift. Spec-driven development mitigates this by using executable specs as authoritative constraints to ensure governed and traceable outcomes. When we converge intent and enforcement, we find that specs are effectively tests. Using frameworks like OPA or Chekhov, we ensure agents only deploy code that mathematically satisfies the original specification. Adopting this approach requires three structural shifts: treating code as a derivative, prioritizing context over prompts, and using executable intent to catch contradictions early. This stack moves from vague vibes and formal specs through modular skills to autonomous agents. A single engineer orchestrating this can achieve the capacity of an entire team. Enterprise governance targets Level 4 spec-anchored development. This ensures that specs and code are version controlled together, providing a continuous audit trail for all architectural decisions. To scale engineer capacity, we orchestrate four modalities: vibes for exploration, specs for blueprints, skills for modularity, and agents for execution. AI execution must be constrained by rigidly gated phases, from initial specification and planning through to task decomposition, implementation, and continuous validation against a core constitution. Framework selection depends on your organization's specific compliance posture and enterprise architecture needs, balancing ease of use with the requirement for strict review gates. By abstracting infrastructure intent through human-in-the-loop gates, we can prevent agent-generated cloud bloat and ensure that business intent is locked before any environment access is granted. Executable assertions replace natural language to enforce compliance. The agent's goal becomes passing a mathematical test, which ensures that only verified infrastructure is deployed. Finally, model context protocols prevent agents from validating their own flaws. By separating back-end validation and front-end mocking, we ensure synchronization across the entire development stack. Let's look at the foundational architecture. Autonomous CI/CD workflows require multi-layered guardrails across input, human intervention, and output to maintain security and reliability. Input guardrails validate user prompts, blocking unauthorized actions to protect resources. Human intervention checkpoints then pause sensitive tasks for explicit approval, while output guardrails scan artifacts for leaks or violations. Furthermore, continuous telemetry and automated rollback mechanisms are essential. They monitor agent behavior in real time, triggering automatic reversals if anomalies are detected in the production environment. High-fidelity AI outputs require explicit and quantifiable specifications. We must move away from subjective descriptions toward testable constraints that define exactly what success looks like. To master specifications, quantify your qualities, anticipate comprehensive edge cases, including failure states, and define binary acceptance criteria that are independently testable as either met or unmet. Avoid common anti-patterns. Do not leak implementation details into business logic specs, avoid over-explaining standard conventions, and always use industry-standard formats instead of creating custom, bespoke documentation. Spec-driven development demands that specifications and source code are immutably bound in version control. CI/CD pipelines should automatically reject changes that lack corresponding specification updates. This model ensures human intent remains the driver of AI systems. It is not just a trend. It is the operating model needed to harness AI velocity while maintaining strict engineering control. The tooling ecosystem is diverse. From GitHub Spec Kit for rigid enforcement to OpenSpec for fluid exploration, and specialized platforms like Tessel, Augment Code, and SpecOps, you have options for every stage. Finally, track your progress using the Spec Rigor Maturity Matrix. We move from Level 0 vibe coding all the way to Level 5 constitutional AI, where humans never directly edit the code. Reaching higher levels of this matrix, particularly Level 5, is increasingly necessary to meet regulatory requirements for high-risk AI systems. Thank you for watching.